Hello everyone, this is Mr. JC. The last video that I posted for you on our YouTube channel was about the exponential and logarithmic functions. We'll continue with the same topic, and I'll first very quickly give you a recap of what we did in our last video, and then we'll continue to achieve our objectives that we set in our last video. We discussed the laws of exponential functions, and I gave you quite a detailed explanation of all these six laws of exponential functions. And then we discussed the properties of logarithm. If you remember, these were the four properties that we discussed, and followed by some questions. It's followed by some questions. I rewrote these properties, and then I asked you to answer these four questions and share your answers with me. I'm going to answer these questions now. As for the first one, as you can see, log 4 1 equals to what? So certainly you can use the first property here. We know no matter what the base of log is, as long as you have 1 after the log, the answer is always going to be 0. So the answer for this is 0. For the second question, you can use the second property. Then we know the log base 2 of an unknown number equals to 1, and that can only happen if the base and the unknown number are similar. So because the answer is 1, therefore the answer for the unknown number should be 2. So the unknown number here is 2. I will leave this one for you. The last part here, once again, as we said, that look at the fourth property here. So log base a to the power r should be equal to r. So the base and the number after the log are the same. Similarly here, 5 and 5. So it means the answer for this question should be equal to 2. Sorry. Moving on. These were the properties, three properties that we discussed quite in detail, and then I solved this question for you, and I solved this one for you, and I asked you to solve the third question. We will continue to solve these questions now, and these were the three questions that I asked you to answer. I will answer the first one for you, or okay, let me answer the second one for you. Here you see ln. ln is actually the natural log. The natural log is a log with the base e, and that is called ln, or natural log. We apply the same properties of log that we applied here. So to answer the second question, there is 2 over 3 before ln. Therefore, according to one of the properties of logarithm that we discussed, the 2 over 3 should become the power of 8. And then we have log, and now we are going to solve this thing inside the bracket. 3 power 4 is 81 minus 8, and 81 minus 8 is going to give you 73. So this is log 73, and 8 to the power 2 over 3 is going to give you 4. So this is log 4. Again, once again, one of the properties of log say when you have two logs with a negative sign between them, it can be written as log 4 over 73. So that's how you answer this question. Let's continue. When we were discussing the properties of exponential functions, we discussed that two similar numbers, if the bases of two numbers are the same, then their powers should be the same. Or in other words, if we have 3 to the power x equals to 3 to the power 5. Now, as you can see, the bases of these exponents are the same, so the powers should be the same. So the answer for this is x equals to 5. We are going to use the same idea for logarithms now. It says that when two logs with the same basis, then the numbers after the logs should be the same. So m is equal to n. Using this, we have to answer a few questions here. I'm going to solve this one for you. So this is not a new property for you. There is a number before the log, so this number should become the power of x. So we have log 5x square equals to log 5 9. Again, one of the properties that we just discussed said that two logs, I mean this property, the same property here, it's log 5 x squared equals to log 5 9. Both the logs have the same basis, so we can easily say that x squared equals to 9. Now, traditionally, x squared equals to 9 should answer in x equals to plus and minus 3. But if you plug log 5 minus 3 into your calculator, I want you to find out what do you get. And can minus 3 be the answer of this question? Please share your answers with me. You can use Google Classroom to reach out to me, or you can just simply send an email. Second question. The second question is again very similar, and we have to use the same property. As you can see, log 5 2x plus 3 equals to log 5 7. Log 5 log 5. So guess what are we going to do? You're right. So 2x plus 3 will be equal to 7. And now it's simple algebra, and you can continue and find the value of x. So in this case, it will be equal to 4 and x equals to 2. Right, these are the two questions, and I want you to try out these questions and find the values of x and share your answers with me in these two questions. And then on Wednesday, as I mentioned before, I'll be online for my online office hour, and then we can discuss these answers. Right, if we have something like this, 2x equals to 32, we can use one of the properties of logarithm to answer this question. It's see, 32 can be written as 2 to the power 5. Do you agree with this? Yes, 2 to the power 5 is 32. Now, because we have the same basis of this equation, therefore, we can easily say that x is equal to 5. This is a very simple question, but we may have something like this. Now, you cannot write 5 as 2 power something. So to answer this question, what we need to do is we need to convert this exponential equation into a logarithm. And you know how to convert an exponential equation into a logarithm. So that's how we proceed. Log, the base of this exponent is 2. So the base of log has to be 2. And all we need to do is we have to change the places of x and 5. So 5 comes after log, and then we have x on the other side. You could use your calculator to answer this question. Now, some of the calculators have something like this, and you can simply plug 2 here and 5 here and find the answer, but some calculators will not have this function. So in that case, you can simply use the change of base function of log, and you can calculate log 5 divided by log 2, and it will still give you the same answer. So in this case, the answer of this is going to be 2.322. I want you to try out this one and find an answer for x, and then share your answer with me through an email. Let's proceed to some complex questions. Here we have 5x minus 2 equals to 3x plus 2. Certainly, I cannot write this 5 as 3 to the power something. So what we need to do is we need to convert this exponential equation into a log equation. I can apply log here and log here, but the question then is, what should be the base of log? To answer that question, we can just simplify the process, and instead of using log base anything, we can simply use log base e, which will be ln. So if I take the log of this side and the log of this side, that's gonna make our work way easier. Now, one of the properties of log said that if you have a number before after the log that has a power, the power comes before the log. So it should become x minus 2 log 5 equals to 3x plus 2 log 3. All you need to do now is expand the bracket, so that would become x log 5 minus 2 log 5 equals to 3x log 3 plus 2 log 3. I'm going to continue with this question on this part. Now, x log 5 makes sense. 2 before the log, so it should become the power of 5. So that would become minus log 25, which is equal to x log 3 cube, which is 27, plus log 9. Bringing the like terms together to find the value of x. So I have x here, the x value here, so I'll bring them together. So I will have x log 5 minus x log 27, which is equal to log 9 plus log 25. Now from the left hand side, if you take x as a common factor, then you're going to have log 5 minus log 27 equals to log 9 plus log 25, and which will eventually becomes x equals to log 9 plus log 25 divided by log 5 minus log 27. And now you can use your calculator to answer this question. I'm sorry, I'm using my mobile phone to write on this PowerPoint. Therefore, the area provided to me to write or the answers is very, very small. But I hope it is clear to you. I want you to answer these two questions, please, and then share your answers with me by email. Let's move on. Solving exponential equations. Solve the following exponential equation that is quadratic in form. Here you can see we have 4 power x minus 2 power x minus 12 is equal to 0. Right. Now, this 4 power x can be written as 2 square power x, because 2 square is 4, minus 2x minus 12 equals to 0. Now, you know 2 times x or x times 2, both are the similar things, same things. So we can always switch their places. So can I write this thing as 2 to the power x square minus 2 to the power x minus 12 equals to 0. That would make our life easier when we are solving this question. Now you can see 2x, 2x. So there is a similarity. I can now suppose that 2 power x is equal to y. If I suppose this, then this thing is y. So we have y square, 2x is y. So this becomes y minus 12 equals to 0. Now it's a very simple quadratic equation, y squared minus y minus 12. And you know how to factorize this equation. To factorize, we will have y equals to 0. Now think of two numbers such that if you multiply those numbers, you get minus 12. And if you add them, you get minus 1. Those two numbers are minus 4 and plus 3. You can check it out. Minus 4 times plus 3 would be minus 12. And if you add the minus 4 plus 3 is going to give you minus 1. So these are two good numbers. So which means two numbers multiplying and the answer is 0, which means either this number is 0 or this number is 0. And from here we can find out y equals to 4 and y equals to negative 3. Now originally y was actually 2x, so I'm going to go back now because y was 2x, so 2x equals to 4 and 2x equals to negative 3. This is easy. We can simply write it down as 2 to the power x equals to 2 to the power 2. But for this one, we need to convert this into log. So log base 2 negative 3 equals to x. Because we have the same bases here, so the powers should be the same. So the answer for this is x equals to 2. Whereas for this one, as you know, you cannot calculate the log of a negative number. That results in infinity, undefined answer. So there is no answer for x in this case. So our only answer is x equals to 2. You can now pause the video and you can see the solution and you can take notes on this. If you have any questions, you can ask me during my online office hour on Wednesday. This is the question that I want you to try out. And again, share your answers with me. Once again, these two questions are very similar to what we just did. So try these questions out and give me your answers. This question says if f of x equals to log 2x plus 3 and g of x equals to log 3x plus 1, then solve f of x equals to 3 and what point lies on the graph. The given information is f of x equals to 3. So we need to use this function because this function has f of x. So according to this, f of x is 3. So I'm going to replace f of x with 3. So I have 3 equals to log 2x plus 3. Now we can always convert this logarithmic equation into exponential equation because the base of log is 2. So the base of exponent should be 2, and then 2 to the power 3 equals to x plus 3. 2 to the power 3 is going to give you 8 equals to x plus 3, which means x equals to 5. Now when x equals to 5, we got this x equals to 5 when f of x was 3. When f of x was 3. And if you can recall, f of x is basically the value of y, right? So when y was 3, we got x equals to 5, which means the point on the graph is 5 and 3. The second part of the question is very similar to what we just did. Now in this case, g of x equals to 4, so which means you're going to use the second function here. G of x equals to log 2 3x plus 1. So just simply replace gx with 4 and then do the same what I did and find the point on the graph. The third part of the question is f of x equals to g of x. So we have to solve this. So we have to basically equate these two equations. F of x equals to g of x. Now f of x is log 2x plus 3. This should be equal to log 2 3x plus 1, and we have to find the value of x. You can use one of the properties of log here. We know when two logs with the same basis, then the numbers after the logs are the same. So x plus 3, we can ignore the logs now. We can say x plus 3 equals to 3x plus 1. And now bringing the like terms together, so x's will be on one side, the terms without the x's on the other side. So I have 3 minus 1 equals to 3x minus x. This gives me 2x and this gives me 2, which means x equals to 1. So this is the answer for the third part of this question. The fourth part says f of x plus g of x is equal to 7. Now to answer this question, f of x plus g of x on the left hand side. of the equal sign. We know the f of x is log 2x plus 3, and g of x is log 2 3x plus 1, and this whole thing is equal to 7. We can again use one of the properties of log, two logs with a plus sign between them. So we can write this expression in the form of a single log, and that would be log 2 x plus 3 times 3x plus 1 equals to 7, which in turn becomes, now let's multiply these two, and then you will have inside 3x square plus 9x plus x plus 3 equals to 7. Now I can convert this logarithmic equation into exponential equation. The base of the log is 2, so the base of the exponent should be 2. So 2 to the power 7 equals to 3x squared plus 10x plus 3. Now 2 to the power 7 is 128 equals to 3x squared plus 10x plus 3, and finally this should become 3x squared plus 10x. If I bring 128 on the other side, that would become minus 128. So 3 minus 128 will give me minus 125 equals to 0. Now as you can see, this is a quadratic equation, and you know how to factorize the quadratic equation. So if you solve this one, this quadratic equation, you will have x equals to 5 and x equals to minus 25 over 3. Now my question to you is, will you take both the values of x? Will you take just one value of x? Or you will not take any values of x that we just found out? Find out your answer, and I would like to know that how did you pick and why did you pick both the values of x, just one of these values of x's, or you didn't pick any one of those. So this is your assignment. You can ask me this question if you cannot figure it out, but I want to figure it out by yourself, and then discuss it with me during my office hour. This question is very similar to number 4, so I'm not gonna do it. You can try it on your own. This question, once again, I have already answered all the 5 parts in the previous slide. So try it out by yourself and see if you can answer that question. The next part is the composite functions, but we have already discussed this, so we are not going to discuss it here. That's the end of this video. Please watch this video, and if you have any questions, you can always reach back to me by email, or just drop a message, and then I'll try to get back to you as quick as I can. Thank you very much, and please do not forget that we have a quiz coming up on these two topics on Thursday. I have already uploaded a homework for you. Try to finish that homework as quick as you can. The deadline for the homework is Saturday, the coming Saturday. Thank you. Goodbye.